All right, we got rational expressions, the first part today of 2. Anytime you see the words rational expressions in math, y'all make you think fractions. That's what it means. It's a fancy word for fraction. First thing we're going to do with the rational expressions is talk about domain. It's a great time to talk about domain. The official definition of domain is a set of real numbers that the variables permitted to have. I always think about like this though. It's like, what are you allowed to put in for x? Like if you look at your variable x or whatever, what can you put in? What are you allowed to put in? And more importantly, what are you not allowed to put in? Okay, got 3 good examples here. This first one, 2x squared plus 3x minus 1, really the only time you have restrictions is if you have a fraction or a radical. And this one has neither one. You could put any number in there for either x you wanted to. So that means the domain here is all real numbers, just big R, all real. You can put anything in you want to. The second one, there's a fraction. Anytime you have a fraction, you got to worry about the denominator. You can never have 0 for denominator. So I'm going to factor that like we did the other day. X minus 3, x minus 2. Now the 2, that gives me 2 terms x cannot be. X cannot be positive 3 or positive 2 because it would both make the denominator become 0. So the way we're going to write domain is we're going to put a little squiggly bar. We're going to put x with the bar. That means all x such that. That's how you would read that. All x such that x does not equal 3. And also x does not equal 2. Kind of fancy, but that's how we're going to go with it. The second one here, one thing about this one is when I look at this part C, I see 2 things that worry me a little bit. First of all, the denominator can't be 0. So I know right off the top, x cannot be 5. Now, the other thing I know is x cannot be negative because you cannot have a negative sign inside your square root, inside your radical. So we're going to kind of write that all out here. We're going to say, okay, squiggly bar, I'm trying. I have a little squiggly bar here, all x such that x cannot equal 5, and also x has to be greater than or equal to 0, which is positive. You can't have 0, I should have said that. You can't have a negative in there, 0 is okay, so that's why I included the 0. So that would be our domain for this one. So you really got to look at the whole polynomial or the whole rational expression and kind of figure that out. What can x be? And more importantly, what can x not be? All right, 3 more quick ones here. Simplifying. If you're just going to simplify, that basically means we're going to put this fraction in lowest terms like you did way back in your lifetime. So that I'm going to factor everything. The numerator is the difference of squares. It's really x plus 1, x minus 1. The denominator, trinomial, is be x plus 2, x minus 1. And what's going to happen, obviously, is the x minus 1s cancel each other. That leaves x plus 1 over x plus 2. And guys, that's simplified. So when it just says simplify, that's how we're going to roll. We're going to factor, cancel as much as we can, and whatever's left is a simplified version. Multiply, same deal here. You got to factor everything, because if you can't factor, you're going to be in trouble. Factor the numerator here. That'd be x plus 3, x minus 1. I'm factoring the denominator here. That's just a x plus 4, because 4 plus 4 is 8. 4 times 4 is 16. Times this numerator here, I'm going to take out GCF, which is 3. That would give me 3 times x plus 4. My denominator is x minus 1. So I'm going to start canceling things. And here's the deal. You can cancel anything on the numerator with anything in the denominator. So I'm going to cancel the x minus 1s. I'm going to cancel the x plus 4s. And because it's all I can cancel, whatever is left will be my solution. So there's a 3 and an x plus 3 in my numerator. My denominator only has one of the x plus 4s. And that's it. That's all you have to do. All right, the last slide, the last thing is just dividing rationals, which is going to be very similar to what we just did. Ever since I've come to web, people have told me this thing about keep, change, flip, and I get it. When you divide fractions, you're going to keep the first one. You're going to change, you're going to change your division to multiplication, and you're going to flip the second fraction. So my first one's going to say the same, except I'm going to go ahead and factor x plus 2, x minus 2. And because this is Precal, I'm going to do 2 things at once here. I'm going to flip and factor at the same time. So I'm going to factor this, which is x plus 3, x plus 2, because 3 plus 2 is 5, 3 times 2 is 6. But it's going to the numerator. I'm going to take the numerator, factor it, which is going to be x minus 4, x plus 1, but I'm taking it to the denominator. And now I'm looking to cancel things. All right, so I see x minus 4 and x minus 4. I see x plus 2 and x plus 2. And that's all. So what that leaves me with for my solution is x plus 3 in the numerator, and my denominator would be x minus 2, x plus 1. A lot of times people will ask me, do I need to multiply out my denominator there? Do I need to do FOIL? And the answer is no. You're fine to leave it just like it is. And guys, that's part one. Domain, simplify, multiply, divide. So you know what's coming tomorrow, right? Addition, subtraction. All right, so see you tomorrow. We'll work on it.